All right, we're at the top of the hour, so we'll get started. Hello and welcome everyone. Thanks for joining us today. We are very excited to have you on. In this webcast, we will be covering how to run serverless on any infrastructure, freeing you from vendor lock-in. My name is Agnes and I work on the marketing programs team here at GitLab. I'm joining you from Jakarta, Indonesia today. We'd love to hear where everyone is tuning in from, so please use the chat function to say hi and tell us where you are in the world. Before we get started, I'm going to cover a couple of quick housekeeping items. First, feel free to ask questions throughout the presentation. You can use the Q&A function at the bottom of your screen for that. We'll have dedicated time at the end of the webcast for questions, but you can go ahead and send in your questions as you think of them, and we'll make sure to get to them at the end. If you're experiencing any technical difficulties, you can use the chat function to get in touch with me, the moderator, for help. We will be sending over the recording from this webcast to all attendees after the webcast is over, so look out for it. Our presenter today is Cullen Taylor, GitLab Technical Marketing Manager, specializing on Cloud Native. We're going to get started with a couple of polls so we learn more about you. With that, I'm going to launch our first poll. All right, thank you so much for participating in the poll. Looks like a majority of you are not yet using serverless in your org today. So you will be glad to hear that Cullen will cover this in great detail today. I'm going to launch the second poll now. All right, for those that are using serverless, looks like a majority of you are using Lambda. And with that, I'm going to turn the presentation over to Cullen. Go ahead, Cullen.
Thank you very much, Agnes. Let me hide these again real quick. I'm actually pretty surprised that it wasn't 100% Lambda. I'm curious as to what those others were, so throw those in the chat if you so desire. Cool. So yeah, this is Unleashing the Power of Portable Serverless. My name is Cullen Taylor. I'm a technical marketing manager at GitLab. I specialize in Cloud Native. Basically, before I was at GitLab, I spent a couple of years as a Kubernetes developer advocate, and then I have a background in like OpenStack ops and like running public clouds and stuff like that before that. So there's my Twitter handle. If you have any questions, please feel free to reach out to me. Either just tweet at me directly, or if you don't want to do that, just DM me. And I'd be happy to answer whatever questions you have. So let's talk about what we're going to talk about today. We'll do like a quick serverless and cloud provider primer, just kind of real short, sweet, and to the point. We'll talk about Knative for a second. And then we'll actually deploy Knative using GitLab, and we'll set up some kind of rudimentary CI/CD pipelines and see how GitLab integrates with Knative. So for those of you out there who aren't using any serverless in your organization today, here's like the most bog standard kind of Webster's dictionary definition of what serverless computing is. So serverless computing is a cloud computing execution model in which the cloud provider runs the server and dynamically manages the allocation of machine resources. Basically what that means is instead of you going and saying, hey, I want a VM, I want it to have 4 cores and 8 gigs of RAM on it, so on and so forth, this much persistent storage. This is just meant to run small bits of code kind of in an a la carte fashion. That way you're only paying for exactly what you use instead of paying like a monthly or hourly rate on that VM we talked about a second ago. So what are some serverless attributes? Basically small discrete units of code. So typically this means you're running a function as a service rather than a full application comprised of many functions, although you can do that too. But most people will tell you to start just with functions, and you'll see a lot of like functions as a service, like FAS type services out there, which we'll talk about here in a second. Event-based execution, that basically meaning that instead of your application running all the time, basically you call it and spin it up as you would calling a function and from a program and doing that programmatically. And that allows you to actually scale to 0. So that means that whenever your functions are not being called, they're not actually using up any resources. And kind of the reverse side of that token is that you're also able to scale to infinity, theoretically, depending on who your cloud provider is and how robust their data centers are. And it lets you use these managed services and kind of further allow you to get off-prem and kind of put some of that burden on somebody else. But there are some problems, and I'm going to take a drink of water real quick. There are some problems with FAS. So cold starts can be a problem. This basically meaning that whenever you do scale to 0 and you're just kind of sitting there at idle, it can be kind of time consuming to go spin up a new machine again whenever your function gets called. These functions also pretty much have to be stateless. I mean, I guess theoretically you could, spin one up and then connect to a database and try to give it some state, but then you're running a persistent database all the time. So, why would you be using serverless? And it's kind of a new paradigm to learn because of this, because it has to be stateless and because you have to assume that either your serverless function or serverless application will spin all the way down. You kind of have to account for that. Security is kind of a new thing, especially since we're off in fully off in container land by this time. Not a whole lot of people are managing entire bare metals or VMs anymore. I mean, obviously there's still a lot of people doing that, but the new cool thing is to do everything in containers, and there's some security problems that haven't quite been figured out with that. And then especially with serverless itself, vendor lock-in is a huge problem. You saw kind of earlier in that poll that most people are using Lambda. I guess it was only about half. That's why I was pretty surprised. Typically, whenever I ask that question, it's like everybody raises their hand for Lambda, for using Lambda is what they're using, and that's it. So it's nice to see that people are using something different now. So here's some things about multi-cloud realities. Enterprises today use multiple cloud providers for various workflows, or they want to at least. This basically lets you use the cloud provider that is best for your workflow, if that at all is a requirement for you. It allows you to do some financial agreements with multiple people. You get to avoid the vendor lock-in that we talked about a second ago. And then this statistic right here, which, oh, dang it, sorry about that. This 85% of enterprises operating in multi-cloud, I don't know how accurate that is. I think 85% of enterprises actually want to operate in multi-cloud, and that's really what this means. But even if that's not a reality, and they want to operate in this multi-cloud sort of fashion, that means they need to have portable applications that can move between those cloud providers, and not be hampered and not have that be a really long or arduous process. Ideally, you would want to be able to do that instantly, and that's kind of what we're moving towards. So if you've ever done any sort of ops work in a cloud fashion, you've probably administrated one or more of these tools. It was my job to administrate a lot of these tools, you know, in a former life. So GitLab is actually a tool that kind of eschews this need for all these separate tools and lets you do a lot of things all in one UI, which is pretty cool. So what have we talked about? We talked about our multi-cloud reality and the need for application portability. We talked about kind of, you know, what serverless is and how it needs to be a first-class citizen. And we talked about the tools chain crisis and workflow portability, which is kind of like the reason for a lot of this and a reason a lot of you are here today. So how do we get there? How do we actually get to cloud agnostic serverless? How do we get to multi-cloud? How do we do this easily without it being a giant migration pain every time we switch between clouds? Right now, there's some pretty common functions as a services out there, Lambda being, you know, the most popular. You have Google Cloud Functions and Cloud Run now, and then you have Azure Functions as well. Those are all pretty, you know, a lot of people are using them and they're fairly common. But there's also another thing you can do. So you can actually run your serverless functions and applications as containers on Kubernetes. So, you know, right now we kind of started with this. We started with bare metals. AWS came along, you know, in the mid 2000s or so, and gave us all VMs, and we were all really happy about it. Then, you know, a bunch of other companies played catch up. It's not just Google and Azure. It's, you know, your DigitalOceans, your Linodes, your various OpenStack companies, your IBMs, so on and so forth. And kind of after we got that down and we got those VMs, you know, down pat, we decided to come up with another thing called containers, and we needed a way to actually manage all those containers, because it's a lot harder to manage, you know, tens or hundreds of thousands of containers than it is to manage, you know, a few hundred VMs. So we decided to go ahead and create this Kubernetes abstraction layer, and that's a nice infrastructure abstraction layer, you know, that lets you talk with a common API to all these cloud providers, or if you just are running your own, you know, Kubernetes clusters on your own bare metals, it's pretty much the same between all of them, which is really nice. And now we're running applications on containers in this Kubernetes abstraction layer. So this brings us to serverless. There's a lot of different ways that you can do serverless, or you can do serverless in Kubernetes in general. There's a bunch of them out there. They're all really, really awesome projects. But for GitLab, we decided that we needed to kind of, instead of having all these different, you know, serverless architectures that are on Kubernetes and picking a different, you know, wool linen suit off the rack, we decided to go with something templated. We want the black t-shirt, we want the simplest approach, and we want to be consistent across the board. So we kind of just landed on Knative. Knative is also, you know, a first-class citizen for Kubernetes. It's you know, it's run by Google right now, and it has not been donated to any foundations or anything like that. But maybe it will one day in the future. But right now, it seems to be the best thing for doing serverless on Kubernetes. So there's kind of three different parts to Knative. There's Knative build, which gets your source code from your repositories. It'll run jobs to install any dependencies and do any testing that you might want to do. before building your container images and pushing them out to a registry. From there, now that you have, your runtime essentially, then Knative can serve your functions. So that way those container images get pulled down, they get started by Kubernetes, and you get that automatic, scaling up and down, and you get to do it all with the Kubernetes scheduler, which is, just really nice and convenient if you're already have a lot of Kubernetes workflows. And then you can also, Knative also has this notion of eventing. So there's tons of event consumers out there. GitLab is one, but basically it can listen for events from all kinds of different sources, and then either build or, kick the tires on your serverless functions. Can't seem to move. So just kind of a recap. We have our infrastructure. We put Kubernetes on top of that to give us, kind of a common API to talk to all kinds of infrastructure from all different providers. We put Knative on top of that to act as, a consistent kind of first-class citizen way of doing serverless on top of Kubernetes. And then to manage all of that, to make things kind of easy, I'm going to show you how GitLab makes both setting up Knative really, really simple, and we'll create some pipelines and deploy some functions as well. So let's go ahead and flip to my demo. Oops. Cool, there we go. All right, so here I have a Kubernetes cluster. That's kind of step one. That's the first thing that you need whenever you're doing Knative. Let me hide these real quick. Cool. So that's kind of requirement number one. Requirement number two is to have some code. That's basically it. That's really all you need. So first thing I'm going to do here, I have a code repository, which is going to define a serverless function, and it also defines a serverless application as well. But before we do anything, we're going to set up Knative. So to do that, we're actually going to go to the operations tab here in GitLab. We're going to go to serverless. Excuse me, we're going to go to Kubernetes. And we're going to add a Kubernetes cluster. We're going to connect this Kubernetes cluster up that I have right here in GKE. I use GKE just because, that's what I have access to. But we could be doing this on EKS or AKS or IKS or whatever Kubernetes service you want out there. We have some integrations to where you can deploy one and have it connect automatically for you. I don't want to do that right now because I don't want to wait on a cluster to provision. So I'm going to just do this manually. So we'll give it a name. I typically name mine the same as whatever I named it in GKE. And then we have to get our API URL. And that's the same across the board. So all you have to do is kubectl cluster info. And that'll give you the IP of your Kubernetes master. So the next two things we have to do is give it a CA certificate and service token. Those will be stored as a Kubernetes secret. But before we do that, let's actually create a service account that will, let us have the correct permissions. So if we get our service accounts right now, we see we just had the default service account. The default service account does not have the correct permissions that we need. So we're going to go ahead and create an admin user. So we will create a user called GitLab admin. Cool. So now we've got our GitLab admin service account, and now we need to grant it the correct permissions. So this command is pretty verbose, so I'm going to cheat here. So what we'll do is we'll create a cluster role binding, and what that will do, or basically what this is saying is, hey, we're going to create a Kubernetes resource type called cluster role binding. It's going to be called, oops. Here we go. It's going to be called GitLab Admin CRB. That way it's the cluster role binding for our GitLab Admin account. The cluster role that we're going to grant it is called Cluster Admin. This is an out-of-the-box role that comes with GitLab that basically just gives the service account permissions to do whatever it wants, essentially. You can define your own roles, or there are also less permissive roles as well. But again, I'm cheating, and this is not a long-winded or a long-running cluster. I'm going to shut this down right after. And then we give it the service account, which is in the default namespace, and it's called GitLab Admin. So now that that's created, we see that we have a GitLab Admin token stored as a Kubernetes secret. And we'll need to extract the CA certificate and the token out of that.
Yes, I'm coming right now. I'll be right
I believe this is it. Let's just make sure. Cool. And kind of the same thing for the token. Let's actually clean that up. Just want to make sure I don't get any extra characters on the cert. Sometimes things can get weird. There's easier ways to bootstrap that out there, but I just wanted to show you how it's done and show you that it's pretty standard. We're just using kubectl commands. We're not really doing anything crazy. This will work on any Kubernetes service out there, or if you run your own clusters, it'll work on that as well. So before we can do anything, what we'll do is install Tiller into our cluster. Tiller is the server-side component of Helm, and Helm is a kind of package manager, quote unquote. It's really more of a templating engine, but it's a way that you install software onto Kubernetes clusters and kind of keep track of their releases. So if we get our namespaces, we see that whenever we connected up our Kubernetes cluster and started installing Tiller, it created this GitLab Managed Apps namespace 16 seconds ago. So let's take a look at what's in that namespace. Oops. Sorry about that. Let's take a look at what's in that namespace. So we see we have a Tiller pod running, and it's been running for about 40 seconds or so. The next things we'll do is install an ingress controller. This will install a Nginx ingress controller. There are many different ingress controllers out there, but Nginx is kind of the standard one. We will install Cert Manager, which will kind of go talk to Let's Encrypt and broker TLS certificates for any application deployments that we make from GitLab into this Kubernetes cluster. We'll install Prometheus just because it gets us some nice metrics along the way. We'll install GitLab Runner. That'll actually execute CI/CD jobs for us in that Kubernetes cluster. And then we need to give this a domain name. So whenever you install Knative, you could go do that using Helm. You could do it in the kind of officially documented way if you wanted to do that manually. But this makes it really easy. And all you really have to do is provide it a domain name, and then it should just go. So if we watch, we see what's going on in our cluster. We see that we have our Cert Manager installation. We see that we have our ingress controller. We see that our install Knative job is running right now. We see that Prometheus has been installed and is kind of coming up right now. And then our GitLab runner is coming up as well. And I think that actually kicked off deployment, which I didn't want that to happen, but it's okay. So let's check what's going on in the logs here. So this should not take too much longer. Okay, looks like it came up. There it goes. Cool. So we see that Knative has been installed. We see that, so Knative brings in Istio as a dependency. So we have an Istio system namespace. We have our Knative build and serving namespaces. So that is all ready to go. And the last thing that we have to do is just create a quick DNS record. I use DigitalOcean to manage my DNS records. You can use whatever you want. And we'll make this kind of short-lived. So what I'm doing here is making a wildcard DNS record. That way knative.eggshell.me redirects to that IP address that popped up here. And also just give it a wildcard one. So anything that falls under knative.eggshell.me will also go to that IP address as well. So basically what happened is that whenever we installed Knative, it went and provisioned its own ingress controller. And whenever you provision an ingress controller on a Kubernetes cluster, that will basically go and broker a load balancer from your cloud provider. So it's actually giving you, a static public IP that is backed by some, whatever their load balancer is. So that's why we're getting actual IP addresses populating here. So with that, we should actually be all ready to go. So let's take a look at our project. See that our deployment failed for some reason. Let's see why. Oh, I think I know what this is. Let's just limit our runners to just that Kubernetes one. Cool. Let's try kicking it off again, but we will take a look real quick. So let's see what we're doing. So in our GitLab CI.yaml, this is just how you define GitLab CI/CD pipelines. We have a whole bunch of templates out there for you. If you want the link to the templates, it's kind of verbose. Here, I'll actually do this. I will throw it in the chat. Because even I have to have it bookmarked. Cool. So all of our, CI/CD templates that we provide to people are at that link. So that's actually what it's pulling in there. So there, within that directory, there is serverless.gitlabci.yaml that's a little more verbose if you really want to dig into the nitty-gritty and see what's going on. But basically what we're doing is we're extending a job definition in there called functions build. We're doing the same thing for functions deploy. We're deploying, GitLab has this notion of environments. So we're actually deploying to an environment, kind of tracked by GitLab that's called production. So you could have one, called test, another one called QA, another one called staging, however you want to manage your environments. And that's really all you have to do. There's not a whole lot of other configuration that goes on, but the next thing we'll check out, if I can load, is serverless.yaml. being slow. Come on, there we go. I'm at a co-working space, so somebody might be, I don't know, torrenting The Watchmen or something right now. Okay, to speed things up, we're just going to look at it locally. Cool. So in our serverless.yaml, this is kind of where we define how our functions are going to run. We're saying that the service that we're going to deploy onto Knative on outloads is a function. We give it, just whatever description we want. Here we're using, telling it which provider we're using. There's a bunch of providers out there. I like Trigger Mesh just because they provide a really good way of interacting with Knative installations. You can pass it environment variables. I'm just kind of including this to show you how to do it. So obviously it's just passing it, foobar. And then here we're actually defining our functions. We've got one called echo.js, the handler. So actually, the name of the function that gets called is echo.js. It's stored within the echo.js directory within this project. The runtime is here. So if you went and looked at this runtime, it basically just defines what container to use or what container image to use whenever this function gets, kind of spun up. So if you go look at this doc file, we're taking a container image of the node function invoker at whatever this get SHA is, and then we're feeding some other environment variables, giving it a package lock and a package.json, and copying some other stuff. And that's about it. We give our function a description, just to keep this file readable. And you can also pass environment variables here. So you can pass environment variables to each function separately, or to every function that you have defined in your serverless.yaml. And with that, let's go actually try to do a deploy. Oops, that's the wrong repository. So we'll just run a pipeline, see what happens. We see we have two stages here in GitLab CI. We have a build stage, which is preparing right now, and then whenever that passes, it'll hand it off to the deploy stage. So in the build stage, we see that we executed a container, and then we started a build. We have a tool called GitLab KTL, which is I forget how it actually works out, but it's basically GitLab's thing for interacting with Knative installations. And what it did is use this thing called Canico, which will do container builds within a container for you. So it did our container build, pushed it, and then, yes, cool. We moved on to the deploy stage, and we see that it deployed successfully. So if we go over into the operations tab and we go to serverless, we'll see that this is the URL for our function. And so let's actually send it a payload real quick. So I just have this little curl script. There it goes. And if we run this curl script to actually hit that endpoint, we see that it actually did something. So all we did was say, hey, whatever I'm feeding you, just feed it back to me. So I fed it a payload in this script. I fed it a payload that said GitLab fast. And then it came back and just gave that JSON right back to me. But the cool thing is that you can actually see the number of pods that are in use. So if I hit this thing 10,000 times, which I'm not going to do, it would actually come back and show me a bunch of pods being in use. And then over time, there's no way to kind of like fake this data with the way that I'm doing this. I'm showing you from having nothing to getting up and running. But over time, you actually get a nice time series graph of the function invocations. So you'll actually see spikes if your functions are getting hit a lot, and so on and so forth. So the last thing, how am I doing on time? I got about 5 minutes left. So the last thing I wanted to show you is that instead of doing just a function, let's say you had something a little more complicated than just one function. Let's say you had like a little image processing application that you wanted to do. That's just an example. It's not the one I actually have here, unfortunately. But for something like an image processing application that maybe has 4 functions in it or something like that, but it's still pretty bite-sized and small, then you can actually deploy a full-on application, and the plumbing kind of works very much the same way. So I just went and uncommented that. We have more stuff in our template that I talked about earlier for actually building the application and deploying the application. Similar, but just slightly different from doing it just for a function. So let's actually go commit. What do we want to call this? We'll just say commenting. Fits. Make sure. Yep. Oh, so we'll push that. Yes, I'm pushing straight to master, but this repo doesn't really matter. So please don't fault me for that. So let's go see how our pipeline looks now. We see that we've now got an applications build, which will go straight to the applications deploy, and a functions build. So those will run as 2 separate jobs. They're running in 2 separate containers concurrently right now on our Kubernetes cluster that we connected up a little bit ago. Kind of the same thing. We're another Canico build, and I'm going to take a drink of water while this spins. Cool. So our function build succeeded. Didn't take that long. The application has slightly more overhead, so it's going to take a second. But let's see what's going on. Sweet. And we're moving. Cool. So I might actually run out of time here, but that's okay. So we've done all this plumbing. We've done all this this neat stuff. But one thing I want to tell you real quick is, we've connected up a Kubernetes cluster. We've installed Knative and Istio into it. We've installed a separate ingress controller. We've installed Cert Manager into it. And Prometheus and GitLab Runner as well. So Prometheus will actually give you some nice cluster health metrics. So you can actually see, I provisioned something fairly beefy for these use case, or for this use case, but I just wanted to show you that you get some decent cluster monitoring right in there. You don't have to go back to your cloud provider just to check if, things are spiking like crazy. And this is the exact same kind of configuration steps that you would have to do to set up what's called auto DevOps. So if you want to do more traditional application deployments on a Kubernetes, this is the exact same process, and you're already set up and ready to go. And you can do this on a per project basis, or you can do it at the group level basis. So if you create a group of projects on GitLab.com, they can all share a Kubernetes cluster, and each of their application deployments will go into their own Kubernetes namespace. And if you do, use our self-managed version of GitLab, then you can do it across your entire instance as well. Kind of a cool note. And let's see if our pipeline finished, because I've got just enough time to show you what I want to show you, if it'll load. Yes, okay, so we completed, our deploy is completed. Let's go back to our serverless page real quick. We see that our function is still there, but our application is now there as well. So you get the same sort of things. And we see that it's running. You would get the same, kind of time series graph of the invocations over time. Just hasn't, drawn yet. Essentially, it doesn't really have any data. And we saw that there was already one pod in use. So when an application gets deployed, it actually gets deployed just to make sure it'll actually run. It'll wait 5 minutes and then it'll spin down. I don't have time to show you that really, but you'll just have to believe me. So with that, I think we are good to go on to Q&A. So Agnes, you want to hop back in here?
Yeah, thank you so much, Cullen, for the informative presentation and demo. We have time later after Q&A. Feel free to pull up the chart if it's finished, or if you want to show anything. But yeah, let's do a bit of Q&A now. We have 2 questions in the Q&A so far, so please submit your questions to the Q&A box if you haven't already. But proceeding with the first question from, so there's an anonymous, somewhat anonymous ask, is there a serverless vendor that provides best, easy solution for HIPAA compliance? I know there is no such thing as HIPAA certification, and that one has to make sure that your own setup is compliant to HIPAA regulations.
So to my knowledge, no. If anybody hasn't figured out, it's going to be Lambda because they've been around for so long. Maybe Google Cloud Run or Azure Functions. But really the reason for that is whenever you get into stuff that is this heavily regulated, like healthcare, for instance, they really don't like you using, they want to keep track of every machine that the data has been passed to. And so whenever you're doing something like serverless or using spot instances or spot VMs, then there's kind of just a fundamental disconnect between where the legislation is for that regulation right now, and kind of where the technology is. And that's kind of the folly of our time, I guess, is that the technology always moves too quickly. So yeah, the answer to that is I don't really know off the top of my head, but that's something I should know. So I'll go look it up later on.
All right, and then feel free to, we'll definitely email you. Oh, but we don't have the email. So, but yeah, if we do, we will definitely reach out with the answer.
Yeah. If you caught my Twitter handle up top, please DM me or just tweet at me, whatever you want to do, and we'll talk about that.
Thank you, Cullen. And the question, Michael asked, will this currently work on all major cloud service providers?
So if you're asking if, the Kubernetes connection that I showed you, yes. I've used it on a ton of different Kubernetes service providers. I just use GKE because, it's easy for me to, mostly for just like company reasons. But it'll work with Amazon's Elastic Container Service, or EKS, whatever they're calling it now. It'll work with Azure's AKS. It'll work with IBM's IKS. That's the great thing about Kubernetes is that it's pretty portable. It's super, super portable. And we're kind of starting to get to this dream where you can truly move between cloud providers with relative ease. So yes, and I've also used it on DigitalOcean's Kubernetes service, and it's worked just fine. So I've never had a problem with it on any of the major ones, at least. Great.
Thank you. And Lucas asked, how to manage useless endpoints in your application?
That's a really open-ended question. I'm not sure exactly what you mean by useless endpoints. Kind of the only endpoints I just created one endpoint. So I'm going to say more clarification on that question as to what you mean by useless.
Sounds great. And then Colin asks, does this work in the EE or CE or both?
So EE and CE have actually had their code bases merged, which is pretty cool. But yes, these features work out of the box with either one. If you're running your own GitLab instance, as long as you stay relatively up to date, then you'll get these features.
Awesome. And I think we have one last question in the chat. Ramdeep asked, what are the GitLab pricing for the serverless K8 functionalities?
So since you're running, GitLab isn't a actual functions service provider. We're just we have a really good way to both install Knative and kind of interact with it and have it really tightly integrated with your code repos rather than actually doing this stuff for you. I just kind of showed you how you use GitLab to deploy all that stuff. So the pricing really depends on the cloud provider that you're running your Kubernetes cluster onto. So I would defer to their pricing pages.
Awesome. Thank you, Colin. If we don't have more questions, I guess we can either, I'm not sure the job finished. Do you want to showcase that or we can?
I mean, I'm pretty good with my demo. The only thing that didn't show up was a time series graph, but kind of what you need for a time series graph to populate is both a bunch of time and a bunch of people to go hit those endpoints. So as far as me just flipping over real quick, that's not really going to happen. But I think the value, has been shown there since I kind of showed you how easy it is. I mean, in 30 minutes we were up and running, and that's all we really had to do. I mean, you can get this going in just a couple of minutes.
Awesome. All right. So I guess with that, if there's no more questions, we can wrap it up. Maybe we'll proceed to the ending slide. All right. So before we end, we'd like to invite you to check out our events page, about.gitlab.com/events. We have events all around the globe, so please feel free to come by and say hi if any of them are in your backyard. We have, people on standby to answer questions. And finally, if you have any other questions, don't hesitate to reach us via our sales contact page, about.gitlab.com/sales. That's all for today. Thank you so much for joining us.